Hey y'all, welcome back. This is the second video on scaling. And this one, I just want to give y'all a concrete algorithm for how to approach these problems, right? Because I know we were kind of just feeling our way through that earlier one with the shrink rate, right? And I want to give y'all a couple of practice problems for how to do this. Okay? So in general, for these scaling problems, there's going to be 3 steps, right? We work through these informally with Alice, right? Let's do this now formally as an algorithm. First step is to identify your scaling factor. Right, let's define that formally now. Scaling factor is the factor by which your object's one-dimensional measurements are being scaled. Right? So for example, in our shrink rate problem, our scaling factor was 1/2. What that meant was that anything on Alice that is a one-dimensional property of Alice, right? Her height, right, from the top of her head to the bottom of her feet, just a straight line, right? And say her wrist circumference, right? It's just a single one-dimensional line that is traced around her wrist. Right? Those get shrunk by a factor of 1/2. Okay, so your first task is to find what is your scaling factor. Second, identify the dimension of the measurement you want to scale, right? So for example, when we were trying to scale up scale down Alice's jean fabrics, right? Jean fabric is measured as a 2-dimensional thing, right? So that would be we record 2D there, right? If we were trying to scale down what her brain size would be, it would be 3-dimensional, right? So we just want to note what kind of scaling are we trying to do, 2D or 3D or even 1D we could have. Okay? And then 3, multiply your measurement that is being scaled by your scaling factor raised to the relevant dimension. Right? So for example, right, we take the measurement that's being scaled, right? So remember that if we're trying to look at the shrink ray version of Alice, we need to start with, well, what was she originally? Her jeans were 14 square feet in fabric. Right? Then that's the number that's getting scaled down. Then we multiply that by our scaling factor that we found in part 1, raised to the dimension that we determined in part 2. Right? So for her jeans, that's 2 dimensions. We multiply by the scaling factor raised to the 2nd power, right? So that her jeans take up 3.5 square feet. Similarly for the brain, right, 1,400, we're going to scale that down to her 1/2 size figure. Right? And then we are going to multiply that as 1/2 raised to the 3rd, because this is her brain is a 3-dimensional thing we're measuring. Okay? So let's do a couple of examples, starting with this one about pickles. So pickles are obviously just cucumbers that have gone through the pickling process, right? But grocery store cucumbers are typically larger than their pickle counterparts, the ones that you would find in jars, right? If you look at the produce section, they're going to be quite large. The cucumbers will be, but the actual pickles will usually fit in a little jar, right? That's because people don't usually want these giant pickles, right? Usually the ones that are selected for pickling are going to be a little bit smaller. Right? So a pickle is usually 4 inches long, and a store cucumber is usually 8 inches long. A pickle weighs 0.1 grams. If cucumbers are really just scaled up versions of pickles, how much do you expect a store cucumber to weigh? Right? One of these large ones you see in the produce section. Go and give your answer in grams at the end, right? But try your hand at this on the form. Go ahead and show all of your steps, right? Find your scaling factor, find what dimension you are interested in, and then find your final answer by multiplying the relevant things. Feel free to toggle back to the steps. Okay, so let's walk through these steps. What's the scaling factor here? Right? Remember that we're trying to scale up the pickle to find measurements about the cucumber, right? This is a kind of estimation that we're doing, right? Kind of like we did on Monday, we're trying to estimate something about the cucumber without actually measuring the cucumber's weight, right? So we're just using the pickle. The scaling factor measures the factor by which we scale the pickle up in the first dimension. Right? So if we can figure out how the pickle's, say, length, which is a 1-dimensional measure of the pickle, changes when it goes from the pickle to this cucumber that we're trying to figure something out about, right? Then that's our scaling factor. So in other words, we want to figure out, if we take this formula, take the pickle length and multiply it by the scaling factor, that becomes the cucumber length. We need to use this formula to figure out what our scaling factor is. Well, if the pickle length was 4 inches and the cucumber length was 8, our scaling factor has got to be 2, right? 8 divided by 4. Okay, so step 1 done. That's our scaling factor, right? All lengths on just one-dimensional lengths on the pickle, right? On the average pickle, right? If I multiply any of those by 2, that will be that corresponding measurement on the average cucumber at the store. Right. Note that the scaling factor we just found does not have a unit, right? The way we solved for the scaling factor was we took 8 inches divided by 4 inches. That means the inches canceled, right? So we were just left with 2, right? So don't panic if you don't know what your units are for. It shouldn't have a unit. Right? This is actually a nice feature. It means that we can actually apply this to scale any units we'd like, including just as long as we're going from pickles to cucumbers, right? So we just did inches to inches. Right? We could also go from feet to feet, just multiply by the scaling factor of 2. We could go from, if we wrote the pickle's length in centimeters, if we just multiply that by 2, we get that's the cucumber's length, right? And this also applies for when we're about to scale up in different dimensions, right? There should be no units on this, so it's really nice to have this general number that we can just apply to any scaling that we want here. Step 2, identify the dimension of the measurement you want to scale, right? We are trying to scale up the weight from the pickle to the cucumber, right? As mentioned in the Alice example, weight is a 3-dimensional measurement. Done. Okay, that's it for step 2. And now we just need to take that measurement that's being scaled and multiply it by the scaling factor raised to the relevant dimension. Right? So we're going to start with the weight that we know, which is of the pickle, right? And then multiply it by the scaling factor raised to the 3rd power, because again, the weight is going to be a 3D measurement. Right? And that should give us the cucumber weight. Right? So if I take the 0.1 grams times 2 to the 8th, I should get 0.8 grams as the expected weight for a cucumber, right? For the big ones in the grocery store. Okay, make sure you are reaching out if you have any questions on this or noting it on the form. Let's do one more example. Let's say you're making a small replica of the Great Pyramid of Giza in Egypt. The real pyramid is 481 feet tall. Your replica is going to be 15 inches tall. The volume of the real pyramid is 91,227,778 cubic feet. What will the volume of your replica be? Okay, so in the previous example, we were scaling up from the pickle to the cucumber. Now we're scaling down, right, from the large pyramid to your little replica. Okay. So try your hand at this also on the form. Make sure you're following our 3 steps. Also make sure you are converting your units as needed, right? Here's the hint. You need to make sure that when you're finding your conversion factor, right, that you are, your scaling factor, that your 2 numbers that your one-dimensional numbers you're converting between are in the same unit. Okay, so make sure you're doing that. Okay, let's go through the same 3 steps. What's our scaling factor, right? Remember, this is our measurement for how much the one-dimensional measurement on the pyramid changes when we go to corresponding one-dimensional measurement on the replica, right? So trying to scale down the real pyramids. Right? Here's the temptation if you're not paying attention to units. It's really easy to say, just try to go from 481 to 15 inches, right? But the problem is this is in feet and this is in inches, right? So this scaling factor is a little bit funky, right? It's gonna have, if I just multiply or divide 15 inches by 481 feet, I'm gonna get inch by feet units, right? And that's not what we want, right? We want our scaling factor to not have units. So in order to avoid that, we need to first change one of these units to be the other units. Doesn't matter which way you go. Here, I'm just going to go from feet to inches, because to go from feet to inches, you just have to multiply by 12, right? So that we have 5,700 and 72 inches. Right? That's how tall the real pyramids are in inches. So now we can actually find the scaling factor. If I'm trying to scale down the height of the pyramids to the height of the replica, I need to multiply by the scaling factor. So I just need to take 15 inches divided by 5,772 inches, and that gets me this tiny decimal, right? Well, again, with no units because it's a scaling factor. All right. Second, identify the dimension of the measurement you want to scale. We are dealing with volume here, so this is a pretty clean-cut example of a three-dimensional scaling again, right? So 3D. And then step 3, multiply your measurement that is being scaled by your scaling factor raised to the relevant dimension. Right? So the volume of your small pyramid is going to be calculated using this formula. You take your original pyramid volume, right, the volume that you actually know, multiply by your scaling factor raised to the third power, because this is a three-dimensional thing we are measuring, and that's going to be the volume of the replica. So we just plug in the numbers that we have here, right? And that will get us 1.6 cubic feet for your little replica. Okay, so I realize now that both of these examples we've worked were for three-dimensional things. If I had asked you to figure out the surface area, for instance, of your pyramid, right? That would be, and I somehow knew the surface area of the large pyramids, you would take the surface area of the large pyramids and multiply by your scaling factor raised to the second power, right? Because that surface area is going to be a two-dimensional measurement. Even though we talk about it on three-dimensional objects, right? Think about, does it make sense to measure this in terms of how much aluminum foil I could put on it, right? If the answer is yes, you're measuring something about that's in 2D, right? So, and that's the idea with surface area. Okay, so that's the end of this video. Please note if you are having any issues on this, we'd love to help, or reach out to us via email or in class. Otherwise, I will see y'all in the next video in a couple of days.